The inversion of AI economics. Inference compute now accounts for 67% of all global AI spend, finally eclipsing the cost of model training as of July 2026. For years, the industry focused on the massive upfront flops required to build a model, but the release of the latest reasoning architectures has shifted the bottleneck to the individual query. We are no longer just looking at a model's weights, we are looking at its budget for thinking time. While legacy models like GPT-4o allocated the same amount of compute to a math problem as they did to a joke, 2026's reasoning models use an adaptive inference scaling approach. This means the model can choose to burn 10 times more compute on a difficult logical verification than on a simple summary. This structural shift moves us away from static parameter counts toward dynamic inference-time scaling laws. How process-reward models scale. The mechanism behind this shift is the process-based verifier reward model, or PRM. Unlike traditional models that only see the final answer, PRMs grade every individual step of a reasoning chain. When a model like O3 Pro generates a response, it is actually exploring a search tree of thousands of potential paths. Think of it like a chess engine for language. If a step leads to a logical contradiction, the PRM penalizes that path, forcing the model to backtrack and try a different branch. This search process is why you see a 20-second pause before the first token appears. The paper on compute optimal inference shows that a small 7 billion parameter model using intensive tree search can now outperform a 34 billion parameter model using standard greedy decoding. It is a win for efficiency, even if it feels slower to the end user. This technical trade-off defines the new scaling curve for reasoning depth. The death of one-size-fits-all scaling. The old chinchilla scaling laws suggested that to get better performance, you simply needed more data and more parameters. But the data from 2026 tells a different story. In math and coding benchmarks like AIM and SWE Bench, the returns on pre-training are plateauing. The real gains are now coming from test-time compute. By allowing a model to spin more flops during the actual generation, we can bypass the limits of model size. However, this comes with a massive latency penalty. We are seeing a divide in the market between small, high-throughput models for chat and heavy-duty reasoning models for engineering. The math shows that scaling inference compute by a factor of 10 can be more cost-effective than training a model that is 10 times larger. This efficiency shift is why labs are now prioritizing reinforcement learning on reasoning chains over raw pre-training volume. The signal under the noise. The fundamental thesis of the 2026 AI landscape is that intelligence is no longer a fixed property of a model, but a variable cost of a query. The transition from pre-training scaling to inference scaling, as seen in the latest ICLR papers, proves that compute-optimal strategies favor reasoning depth over raw parameter volume. For builders, this means the unit economics of AI have changed from paying for speed to paying for correctness. We have moved from the era of tokens per second to the era of logic per dollar. As the industry moves toward agentic systems, the ability to dial up reasoning effort for a specific task will be the primary lever for performance. This changes everything for infrastructure planning, as the demand for high memory bandwidth hardware for inference will only intensify. Watch for the next major benchmark updates in late 2026, where we expect to see even smaller models using dense search to bridge the gap with the trillion parameter giants. Subscribe for more